Hello everyone, I am Dr. Venkateswararao. In the last videos, we had gone through the concept of pH, and from the various videos of pH concept, we came to know the two definitions for pH. That is, pH is negative logarithm to the base 10 of concentration of H plus ions. pH is negative logarithm to the base 10 of concentration of H plus ions. And another definition that we came to know from the last videos is that pH is negative logarithm to the base 10 activity of H plus ions. So these are the two definitions for pH. Often we usually follow the definition of pH is negative logarithm to the base 10 of concentration of H plus ions. Most of us we do not use the definition of pH. pH is equal to negative logarithm to the base 10 of activity of H plus ions. So this is the formula to calculate the pH of high concentrated solutions, that is more than 0.1 normal, and this is the formula by which allows to calculate the pH for low concentrated solutions. I repeat, pH is equal to negative logarithm to the base 10 of concentration of H plus ions. This formula allows us to calculate the pH of low concentrated solutions, that is less than 0.1 normal concentration, and this is the formula pH is equal to negative logarithm to the base 10 activity of H plus ions. This formula allows us to calculate the pH of high concentrated solutions. Okay. So usually in general we often use the formula of pH is equal to negative logarithm to the base 10 of concentration of H plus ions. So pH is equal to negative logarithm to the base 10 of concentration of H plus ions. And one more thing that you should keep in your mind, that in pH calculations, whether it is pH is negative logarithm of concentration of H plus ions or pH is negative logarithm to the base 10 activity of H plus ions, in every pH calculations concentrations should be expressed in normalities. I repeat, in every pH calculations or pH, in the calculation of pH, we should express the concentration of H plus ions in normality only, right? Okay. So pH is equal to negative logarithm to the base 10 of concentration of H plus ions. We can write this equation when we multiplying this equation with the negative sign, that is negative pH is equal to logarithm to the base 10 of concentration of H plus ions, and if a concentration of H plus ions is equal to log, when we take this log to this side, then this negative sign of pH becomes 10 power minus pH. 10 power minus pH. I repeat, okay, negative, when we multiply this equation with the negative sign, this becomes minus pH minus plus logarithm to the base 10 of concentration of H plus ions, and if we take this logarithm on this to this side, then this logarithm becomes 10 power minus pH, because it is a Briggsonian logarithm. Okay, you should keep this point in your mind, that it is a Briggsonian logarithm. If it is Neperian logarithm, it becomes e power exponential power minus pH. right. So concentration of H plus ions is equal to 10 power minus pH. Okay, so this is the very important equation which allows us to calculate the pH of various solutions, right. Okay, so if concentration of H plus ions is equal to 10 power minus pH, okay, it is okay. Then when now we shall see calculation of pH. Now we shall see the calculation of pH. Okay, so there is a simple formula to calculate the pH of solutions. That formula is if concentration of H plus ions is equal to 10 power minus x, if concentration of H plus ions is equal to 10 power minus x, then pH is equal to, then pH of the solution is equal to x, then pH of that solution is equal to x. This is the first formula, and the second formula is if concentration of H plus ions is equal to x into 10 power minus y, then pH is equal to y minus log x, y minus log x. I repeat, if we know the concentration of H plus ions in the 10 powers, that is, if it is concentration of H plus ions is 10 power minus x, then pH of the solution is equal to x. Similarly, if concentration of H plus ions is equal to x into 10 power minus y, then pH is equal to y minus log x. These are the two formulas. That two formulas allows us to calculate the pH of various solutions. Okay, and one more thing is that we know the concentration, we know the pH of neutral solutions, we know the pH of acidic solutions, we know the pH of basic solutions. Generally for neutral solutions pH is 7, and for pure water concentration of H plus ions pH is equal to 7 and pOH is equal to 7. Let us go through the pH calculation in detail. Okay, for neutral solutions I am going to calculate at 25 degree centigrade, and at any temperature, Why? Because already I told you that pH scale, Sorensen proposed the pH scale based on the ionic product of water. Okay, and we know that the ionic product of water is temperature dependent. We know that ionic product of water is temperature dependent. With increasing the temperature, ionic product of water increases, right. For neutral solutions at 25 degree centigrade, concentration of H plus ions is equal to 10 power minus 7 and pH of the solution is 7. How would I know the if the concentration of H plus ions is equal to 10 power minus 7, then I can simply write the pH of the solution as 7. How can I write that? Because we know the formula, concentration of H plus ions is equal to 10 power minus x, then pH is equal to x. So similarly, if it is for neutral solutions, the concentration of H plus ions is equal to 10 power minus 7 and pH is 7, and concentration of OH minus is 10 power minus 7 and POH is 7. This is at 25 degree centigrade, and if it is at any temperature, concentration of H plus ions is equal to root kW. If you find out the root for ionic product of water, actually ionic product of water is 10 power minus 14. If you find out the root for ionic product of water, that comes out to be 10 power minus 7, right? And pH is equal to pKw by 2, pKw by 2, okay, and concentration of OH minus is equal to root kW and POH is equal to pKw by 2. That is, and this is at 25 degree centigrade and this is at any temperature, right? And for acidic solutions, concentration of H plus ions is greater than 10 power minus 7 and pH of that solution is less than 7, okay. And for this, at any temperature, concentration of H plus ions is greater than root kW and pH is less than pKw by 2, right. If for acidic solutions, concentration of OH minus is less than 10 power minus 7 and POH is greater than 7, and for concentration of at any temperature, concentration of OH minus is less than root kW and POH is greater than pKw by 2, and for basic solutions, concentration of H plus ions is less than 10 power minus 7 and pH is greater than 7. This is at 25 degree centigrade, and if you want to calculate the pH at any temperature, concentration of H plus ions is less than root kW and pH is greater than pKw by 2, and concentration of OH minus ions is less than 10 power minus 7, greater than 10 power minus 7 and POH is less than greater than 7, and here this is at 25 degree centigrade and this is at any temperature. You should keep this point in your mind, okay. And concentration of OH minus is greater than root kW and POH is greater than pKw by 2, okay. So these are the formulas, okay. What I want to say is that at 25 degree centigrade, concentration of H plus ions is equal to 10 power minus 7 and the concentration of OH minus is 10 power minus 7 and pH for that solutions is 7, but with increasing the temperature, ionic product of water increases, and we know that Sorensen formulated the pH scale based on the ionic product of water, but ionic product of water is temperature dependent. With increasing the temperature, ionic product increases. So ionic product increases, pH values also varies. Okay, so at any temperature, concentration of H plus is equal to root Kw, and we can with the use of these formulas we can calculate the pH of any solution at any temperature. Okay, so before we are going to solve a few problems, I shall sum up this class in 2 points. We know from the last videos we came to know the 2 definitions for pH. pH is negative logarithm to the base 10 of concentration of H plus ions, and pH is equal to negative logarithm to the base 10 activity of H plus ions, right? And in the pH calculations, concentration should be expressed in normalities, right? Concentration should be expressed in normalities. And another point that you should keep in your mind that Sorensen proposed the pH scale based on the ionic product of water, but ionic product of water is temperature dependent. Okay, let me clear this concept with a simple example. Let me clear this with a small example. We know that Kw is equal to 1 into 10 to the power of minus 14. Usually it can be written as 10 into 10 power minus 14. It is at 25 degrees centigrade. It is at 25 degrees centigrade. Ionic product of water is 10 power minus 14. At the decreasing the temperature at 0 degree centigrade, that means we are decreasing the temperature, that Kw is found to be 10 power minus 15. What happens here? With decreasing the temperature, ionic product of water decreases, because the 10 power compared with 10 power minus 14, when we compare the 10 power minus 14 and 10 power minus 15, 10 power minus 15 is less than 10 power minus 14. That means with decreasing the temperature, ionic product of water decreases. And if we increase the temperature at 60 degrees centigrade, for example, if we increase the temperature up to 60 degrees, that Kw is found to be 10 power minus 13. This means that when we increase the temperature from 25 degrees centigrade to 60 degrees centigrade, ionic product of water increases from 10 power minus 14 to 10 power minus 13. 10 power minus 13 is greater than 10 power minus 14. Okay, so with increasing the temperature, ionic product of water increases. Okay, at 25 degrees centigrade, pH scale ranges from 0 to 14. At 0 to 14, but at 0 degree centigrade, pH scale ranging from 0 to 15. But at 60 degrees centigrade, pH scale ranging from 0 to 13. Okay, these are the very important point that you should keep in your mind. At 25 degrees centigrade, pH scale ranging from 0 to 14. At 0 degrees centigrade, pH scale ranging from 0 to 15. At 60 degrees centigrade, pH scale ranging from 0 to 13. Because why? Because pH scale proposed pH scale is proposed based on the ionic product of water, right. Okay. So, a neutral solution at 25 degree centigrade, a neutral solution of pH is neutral solution has pH 7. At 25 degree centigrade, neutral solution has the pH value 7. At 0 degree centigrade, neutral solution has the pH 7.5. But at 60 degree centigrade, pH for neutral solution has pH 6.5. Okay. All these three are neutral solutions, but these are at different temperatures. For 25 degree centigrade, neutral solution has pH 7. At 0 degree centigrade, neutral solution has pH 7.5. At 60 degree centigrade, neutral solution has the pH 6.5. Right? You should keep these points in your mind. Okay. Now we shall do some problems. Okay. Here the problem is hydrogen ion concentration in a sample of soft drink is 3.8 into 10 power minus 3 molar. What is its pH? Okay. So, what is given? They given that hydrogen ion concentration in a sample of soft drink, that is concentration of H plus ion is 3.8 into 10 power minus 3, 10 power minus 3, and they asked to find out that what is the pH of that solution. We know very simple, we know the pH is negative logarithm to the base 10 of concentration of H plus ions, and we know that if concentration of H plus ions is x into 10 power minus y, then pH is equal to y minus log x. Same formula, we can apply the same formula here. So, here pH is equal to negative logarithm to the base 10. What is the concentration of H plus ions? 3.8 into 10 power minus 3. Okay. If concentration of H plus ions is 3.8 into 10 power minus 3, that is y into 10 power minus x, then we can write the pH of the solution as y minus log x. So, similarly we can write y, what is y here? 3 minus log 3.8. Okay, no need to calculate this logarithm, and you put forward this minus 3 to up to before logarithm. No need to do all these calculations. Here we can observe that concentration of H plus ions is x into 10 power minus y. It is in the form of x into 10 power minus y. Then we can easily calculate the pH of the solution as pH is equal to y minus log x. So, here y is 3 minus log x means 3.8. So, 3 minus log 3.8 that is 0.57. That is 0.57, and it comes out to be 2.43. Here is the another problem, that is calculate the pH of 10 power minus 3 molar H2SO4 solution. Okay. So, pH is of 10 power minus 3 molar H2SO4 solution means that concentration of H plus ions is 10 power minus 3 molar. I already told you that in pH calculations, in all pH calculations, concentration of H plus ion should be expressed in, must expressed in normalities. Okay, and H2SO4, and we know that normality is n factor into molarity, n factor into molarity. Here the n factor is basicity of acid, acidity of a base. Okay. So, since H2SO4 is a dibasic acid, that N factor is 2 into molar, and normality of given H2SO4 solution is 2 into 10 power minus 3 mol normal. And we know that normality means concentration of H plus ions is 2 into 10 power minus 3. It is in the form of x into 10 power minus y, then pH is equal to y minus 10 y minus log x, that is 3 minus log 2, and we know the log 2 value as 0.3, and it comes out to be 2.7. And here is the problem 3, that is calculate the pH of 10 power minus 8 normal HCl solution. It is very interesting problem. Okay. So, here 10 power minus 8 normal HCl means concentration of H plus ions is 10 power minus 8 normal. For HCl, normality and molarity are equal because N factor is 1. When N factor becomes 1, then normality is equal to molarity. So, here the concentration of H plus ions is 10 power minus 8, and we know that if concentration of H plus ions is equal to 10 power minus 6, then pH is x. Similarly, here the concentration of H plus ions is 10 power minus 8. That means the pH of that solution is 8. But pH 8 means, and pH of the solution is 8, but this is wrong. Why? Because pH 8. Okay. So, when the value pH value exceeds 7, that indicates the base. Okay. For acids, that pH value of the acids should be less than 7, but here pH is comes out to be 8, and we know that concentration of H plus ions and pH are inversely proportional. If concentration of H plus ions are increases, pH value decreases. If concentration of H plus ions decreases, pH value increases. Here what happens? pH value increases, that means concentration of H plus ions decreases. Okay. So, how can we solve this problem? Okay. So, here the concentration of H plus ions is 10 power minus 8. Okay. This is the HCl solution. HCl solution means in that solvent is water, and we know that the concentration of H plus ions in 1 liter water as concentration of H plus ions in 1 liter water is 10 power minus 7. How would we know? How would we know that? We know that concentration of H plus ions is 10 power minus 7 molar. That means if you take 1 liter water, the concentration of H plus ions is 10 power minus 7. Right. So, concentration of H plus ions is 10 power minus 7. Okay. So, 10 power minus 7 is greater than 10 power minus 8. Already I told you that H plus concentration of H plus and pH are inversely proportional. pH increases, concentration of H plus ions decreases. Concentration of H plus ions increases, pH decreases. But what happens here? pH increases for the acidic solution. That means concentration of H plus ions in the solution is very less. In such conditions, in such solutions where the concentration of H plus ions are less than 10 power minus 7, I repeat, where the concentration of in solutions where the concentration of H plus ions are less than 7, then we should take the concentration of H plus ions of water, because all these solutions are made by solvent water. And already I told you that Sorensen formulated the pH scale based on the ionic product of water and water as a solvent, and water as solvent. Okay, so that's why when we take concentration of H plus ions in calculation of pH, we should take the concentration of H plus ions when the concentration of H plus ions of the given solution is less than 10 power minus 7, then we should take the concentration of H plus ions of water. So here the concentration of H plus ions is H plus ions from water is 10 power minus 7 and H plus ions from solution is 10 power minus 8. Why we take this 10 power minus 7? Because here the concentration of H plus ions is 10 power minus 8 and this is 10 power minus 8 is less than 10 power minus 7. Only in such cases we should take the concentration of water. Okay, so 10 power minus 7 plus 10 power minus 8. Okay, if you take 10 power minus 7 common, 1 plus 10 power minus 1. Okay, so 1 power plus 10 power minus 1 means 10 power minus 7 and 10 inverse means 0.1 and it is 1.1 and this is 1.1 into 10 power minus 7. So here the concentration of H plus ions is 1.1 into 10 power minus 7, but in the earlier case concentration of H plus ions is 10 power minus 8. What we do here in this problem, we actually concentration of H plus ions is 10 power minus 8. Okay, H plus ion and pH are inversely proportional. H plus ion's concentration increases, pH decreases. But what happens here? pH increases, concentration of H plus ions decreases. So here the 10 power minus H plus ions is 10 power minus 8. That's why we increase the concentration of H plus ions to 1.1 into 10 power minus 7 by adding the concentration of H plus ions of pure water. Okay, so here the concentration of H plus ions is 1.1 into 10 power minus 7 and it is in the form of x into 10 power minus y, then pH of that solution is y minus log x. So 7 minus log 1.1. Okay, 7 minus log 1.1 is that comes out to be 0.04. So it comes out to be 6.96. So 6.96 pH is less than 7 and it holds good holds good according to the Sorensen pH scale, because in Sorensen pH scale ranging from 0 to 14 and for acids pH is less than 7 and it holds good for and that Sorensen scale is holds good when we take the concentration of H plus ions into consideration. Thank you. Okay, and here is the problem 4, that is calculate the concentration of a hydrogen ion in the acidic solution with the pH is equal to 4.3. Okay, so here the reverse calculation. Okay, up to this problem we calculate the pH basing on the value of concentration of H plus ions, but here we calculate the concentration of we are going to calculate the concentration of H plus ions with the use of pH value. Okay, so for solving this problem, we know that pH is negative logarithm to the base 10 of concentration of H plus ions. Here the pH is given as 4.3 and it is a minus logarithm to the base 10 of concentration of H plus ions. Okay, if we multiply this equation with the negative sign, that is minus 4.3, then it becomes plus log 10 concentration of H plus ions. Okay, minus 4.3 can be written as minus 4 minus 0.3. Okay, so minus 4 and minus 0.3, that comes out to be minus 4.3. That's why I shall write this minus 4.3 as minus 4 minus 0.3. For the sake of my convenience, I add plus 1 and subtract -1 for the sake of my convenience. Okay, so and log based on concentration of H plus ions. Okay, and we can write -4 and -1. Okay, this can be written as -5. This can be write as -5 and +1 0.3. So that is 0.3 should be subtracted from 1.1. Okay, so that comes out to be 5.7. That is comes out to be 5.7. Okay, and it is equal to logarithm to the base 10 of concentration of H plus ions. Okay, so and concentration of H plus ions is equal to concentration of H plus ions is equal to logarithm. If you drag this logarithm to this side, it becomes anti-log of minus 5.7. So anti-log of minus 5.7 is comes out to be 5 into 10 power minus 5. How is equal to concentration of H plus ions? How can I write this? Minus 5 can be written as 10 power minus 5 and the anti-log of 0.7 is 5. Okay, so 5 into 10 power minus 5 is the concentration of H plus ions. Okay, so in this way we can calculate the pH of various solutions, and of course in the later videos we shall calculate the pH of mixed solutions and pH of the weak acid and pH of the weak bases. Okay, I hope you all understood these problems. Thank you.